Question number 4 in chapter 19 of the textbook, it reads, a 1.5 volt dry cell can be tested by connecting it to a low resistance ammeter. It should be able to supply at least 22 amps. What is the internal resistance of the cell in this case, assuming it is much greater than that of the ammeter? Um, this problem requires you to make a couple of assumptions. First, let's go ahead and sketch the circuit. I've got my 1.5 volt dry cell. It's got an internal resistance, which I'll draw as a resistor here. And then we've placed an ammeter here in the circuit. This ammeter is in series with the circuit. And then I'll close the circuit here. I'm going to draw kind of a dashed line here around this battery and internal resistance. So we're going to say this would be terminal B, this would be terminal A. So therefore, these are the terminal voltages, and they're going to be separate from the EMF of the battery. So we know the EMF of the battery, this rated battery voltage, is 1.5 volts. However, we do know that there exists a relationship VBA, this is the terminal voltage, is equal to the rated EMF minus the total current minus the resistance. Excuse me. In this simple circuit, we know a couple of things already. We know that the maximum current that it should be able to supply is 22 amps. And we know the rated capacity of the battery, it's 1.5 volts. So we know a couple of things in here. We also know that as this component here, the current times resistance, let's remember that is the internal voltage drop, if you will, due to the internal resistance. So as the current in the circuit goes up, this value goes up. The internal resistance doesn't change. And at some point, it can only increase up into the point where it's equal to the rated capacity of the voltage. In other words, the terminal voltage is equal to 0 when we've reached this maximum current, the maximum ability of the battery to supply charge flow or current. So we know that this occurs when this is equal to 0. And we're ultimately left with the EMF of the battery, or its rated voltage, is equal to the internal resistance times the total current coming out of the battery. At this point, it's pretty straightforward to solve. I'm solving for the internal resistance R of the battery. That's going to give me E over I, or in this case, the 1.5 volts over the 22 amps. And when I do that, I get 0.068 ohms as my answer for the internal resistance of this battery.